At Ambar Kelly, we work predominantly in the riser shafts with our riser safe product, and our approach is to make things as easy as possible for the design team, the main contractors, and also for clients. And we do this with the design team by mitigating the risks associated with falls and fire within risers, and for the main contractor, increasing the buildability, making sure things work better, and for the client and PQS, we reduce the cost of the risers to the project. The main challenges we have with architects is making sure they have the details correct for compartmentation within the risers. It can be simple things like whether the steels surrounding the risers are properly fire wrapped, and for structural engineers to ensure the slab overhangs that steel by at least 50 millimetres so you can get a three-sided encasement. Going on to looking at the main steels coming through the riser, ensure that they're encased. What all of this is doing is reducing the size of the riser. We need to make sure that that's been taken on board so that when the M&E contractor comes on board to bring their services through, they only have to design it once, having taken into account this. The other one that's catching a lot of people out at the moment is deflection heads within plasterboard walls in risers. EN 1364 Part 1 means you've got to have a much wider encasement. Even if your wall's 100 millimetres wide, 102 mil wide, your beam encasement will end up being 250 mil wide. This eats into the riser. And it's nothing to do with riser safe, it's just part of the service that we do to ensure the space available for the M&E service is correct. In the designer's risk assessment, and they'll carry out probably REBA stage 2, they'll always identify the riser shaft as having a risk of falls, and that means it has to be mitigated by some method, which the main contractor can do. But they rarely put that in as a path for fire of smoke and flame. And as we've seen in recent tragedies, that if you've got combustible materials in a shaft or a space, then that can be a major issue. So the designer's risk assessment for risers, we believe, should include the risk of propagation of fire from it. With regard to fire, there's been an old national standard, BS 476 Part 6 and 7, has been taken out of the approved document B from March 2025. The reason for that was in the Grenfell inquiry, they found that the Class 1 and Class 0 spread of smoke and flames wasn't really relevant to the actual combustibility of materials. So materials that were given under the national standards, a Class O standard, could be Class B, C, D or E in the Euro class combustibility standards. So with that being taken out, all products now have to have a Euro class rating, and that's going to affect all products that only currently have a BS 476 Part 6 or 7 rating. Riser safe, being made of steel, is categorised as Euro class A1, which is non-combustible. We also work with third-party contractors or suppliers of fire-stopping products such as Rockwool, where riser safe acts as the permanent formwork to pour on fire-stopping compound to give 2 hours horizontal fire protection in riser shafts. So riser safe is class A1, so it's non-combustible. We also are the substrate for the fire-stopping compound to give a horizontal fire protection, and by the very nature of the product, we bring the riser shaft in over the edge of the steels, so the concrete can be poured against it to allow three-sided encasement for the beams around the riser shaft. That's quite an interesting one. Will always be more expensive in the initial outlay, which will be in the structural frame package. But as the project goes on, there's no more cost associated with riser safe. But you get increasing costs with GRP packages. You'll have to provide temporary doors with it, protection to it, handrails around it. You then have to cut holes through it, and then you have to re-support it. So the cost builds up with the GRP and will end up being 30 to 50% higher than the riser safe cost over the duration of the project. The gateways have been brought in by the Building Safety Act, and it's a way to control the materials that are used in the building. We're normally dealing with Gateway 2 and 3. So materials that are specified in Gateway 2, if they're non-combustible, and the main contractor or their subcontractor wants to change something to a different material where they don't know the combustibility or it is combustible, they have to go through a change control process, which the main contractor has to run, and that has to go back to the designers and possibly the client to get signed off. What are the reasons? What's the safety case for it? If they don't do that, When it gets to Gateway 3, building safety regulator could will look at the information and say that doesn't pass. You cannot get through Gateway 2, you cannot hand your building over. So it's absolutely key to get these things closed out in the change control process. And if they don't, you may not get through Gateway 3, which means you won't be able to hand your building over. My advice to the architect and the main contractor would be, if you're offered an alternative product, look at it. Look at the safety certificates that come with it, the fire certificates, make sure it's third party, and make sure it's a relevant test for the product that's being put in.